Hey there, everybody. It's Mr. Sheline here. Welcome to the Unit 2.2 notes for atomic structure. We're going to be getting into more or less some stuff that you know that you should remember a little bit from last year, maybe the year before at middle school, and then kind of expanding on a little bit, and then getting back to reading the periodic table, knowing how to read it and knowing what to do with it, really. Okay, so let's get right into it, guys. So here are the learning objectives. So I know the learning objectives usually are on your notes. I just was in such a rush the other day, I didn't get them on there. But here is what these are your learning objectives for this particular section is. I can identify and list the characteristics of the subatomic particles. I can read and apply the information in the periodic table to a question about the characteristics of an atom. And I can use both the information from the periodic table and my knowledge of the atoms to create models accurate representing their properties, specifically, the properties of the atom, okay, or of a particular atom. So what is an atom? So remember, an atom is the smallest particle of an element that retains the chemical identity of said element. Okay, so even though we can break, there's smaller parts that make up an atom. For the most part, protons are just protons floating around. If they're just protons, they don't really tell us what kind of thing you have. You have to have a number of protons and a number of neutrons and a number of electrons to have something with a consistent property or properties. And so atoms are made up of these things that are called subatomic particles. And what are those? Well, they're just the particles that are smaller than an atom. And there are more than three. There's a decent number of different types of subatomic particles. We're only going to focus on three of them. So the three that we focus on are the three that primarily make up an atom. And then those are going to be the neutrons, the protons, protons, and then the electrons. Okay. So let's take a look here. So real quick, before we can go through, what each of the, what the characteristics of each of these pieces are, these subatomic particles, we got to remember where these are located at. So protons and neutrons they're the ones that are going to be located in the nucleus, while the electrons are found outside of the nucleus in what are called the electron clouds. There's other models that call it the, different energy levels. So you can just say outside of the nucleus. That works too. So what is the nucleus? Well, the nucleus is a small, dense region consisting of just the protons and the neutrons at the center of the atom. Okay, so it's super dense. A guy named Rutherford was the one that discovered this. He more or less shot some lasers through some gold foil, and notice he was able to accurately, measure the angles of where the lasers deflected, and was like, that's kind of weird. Something must be bouncing those off. And so he made the idea, he concluded with the idea that, there must be a whole bunch of stuff just packed in the center of these atoms. And he's like, that must be the nucleus. Yay. But anyway, we'll get into that later. Not in these notes, but later notes. But so let's go ahead. On your notes, there's that little there's that little drawing to the side there on your notes. Go ahead and let's start labeling that. Label where the nucleus is at, label where the neutrons are, where the protons are, where the electrons are. Okay, so then while you're doing that, let's get into the characteristics of neutrons. So neutrons have a mass of about 1 atomic unit. And those are the more or less the mass units. This is just how we measure them. Understand that, obviously, they're super crazy itty bitty, teeny tiny little things. But we associate this particular kind of measurement. It's a rough measurement of how much a proton, the mass of a proton has and the mass that a neutron has. And they both will have 1 atomic mass unit. And that's what the AMU there stands for, is atomic mass unit. So again, we find the neutrons in the nucleus. They have no charge. And when we write down their symbol, there's other ways that you can write a symbol. So there's N. Another one looks like this. It's like N, and then with a little circle up top with a slash through it. let's just focus in on N. If I write N down, just know I'm talking about neutrons. Okay. Okay. And then protons. So protons also have a mass of 1 AMU, 1 atomic mass unit. They are also found in the nucleus. These guys have a positive charge, and their symbol is P. So similar to neutrons, protons also they've got this symbol. It's a P with the plus sign up top. Again, I'll just be using this one for you guys for the most part, so just pay attention to that. But this is another way you can write their symbol. Okay. And then the electrons, they virtually have no mass. So electrons have pretty much they're more or less just negative energy. They're I shouldn't even say negative energy. They are just they are it's energy found on the outside, little particles of energy found on the outside of the nucleus, and they just don't have a whole lot of mass to them. So little, in fact, that it's negligible. We just don't really mess around with it all that much. So they're found outside the nucleus. These guys have a negative charge, and their symbol is E. Another way to write their symbol is an E, and if you probably guessed it already, it's going to be E with a little negative symbol up top, like that. Okay, like that. Okay, easy peasy. So let's just use this, or go through this, check your understanding number 1. So I'll read through this, and after I'm done reading through it, pause the video, and then try to attempt this, check your understanding on your own. After you've attempted it, hit the play button again, and then I'm going to go through it with you to, to show you what I'm looking for here. So pause the video. Okay, so what I was looking for here as far as a data table is concerned, I was looking for this. So you could split this up. You could split this up way over here. It'd be like SP is going to be subatomic particle. That's what I'm thinking. There's subatomic particle for SP. And so I'm going to use the symbols here. So neutrons, protons, and electrons. Okay, split them all up. And then here we can have mass. So the mass of a neutron is 1 AMU. The mass of one proton is 1 AMU, and the mass of one electron is 0 AMU. Okay. So we got mass. So then we can maybe do location. So locale. I'm going to put NUC is going to be nucleus. Okay, nucleus, and then maybe outside nucleus. For electrons, next one would be charge. So what are the charges of all these guys? Well, neutrons have no charge, protons have a positive charge, and then electrons have a negative charge. Oh, now I'm losing my train of thought here. There should be one more. Let's see, location, mass. I got to cheat real quick. Got to look back at the notes because I've already forgotten. Oh, I guess I already have them. So yeah, this is what I'm looking for here. Here, I'm going to get rid of this over here. This is what I'm looking for. So yeah, so the mass of our neutrons here, 1 AMU. Mass of our protons here, 1 AMU. Nothing for the electrons. Both the neutrons and protons are found in the nucleus. Electron is found outside the nucleus. Neutrons have no charge. Protons have a positive charge. Electrons have a negative charge. And that's what I'm looking for here. Okay. So let's get into the periodic table now. So now we've seen the periodic table before. We probably have read it. We've used it in the past, I'm sure. But just to recap, we categorize atoms based upon their multiple characteristics, and we even give them names based upon these characteristics, and we organize all of them in a very particular, very specific manner based upon those characteristics. Now, the term that we use for each of these guys in here, we do say there are atoms, like there's an atom of carbon, there's an atom of helium, whatever it is, but those are elements, like helium and carbon, boron, thallium, they're all elements. And then elements refer to the pure substance which cannot be broken down by chemical means. and consist of atoms which have identical numbers of protons in their nuclei. Okay, and nuclei is just nucleus plural. Okay, so if you have a number of carbon atoms, you have all the nuclei, all the different all the different nuclei. Oh boy, it's referring to all of the individual nucleus. So I'm trying to say it without saying like gooses, basically. Regardless, nuclei is just the plural version of nucleus. So anyway, I think you get the picture. So examples of elements: carbon, oxygen, nitrogen, hydrogen, lithium, magnesium, beryllium, scandium, thallium, nickel, copper, gold, silver, you name it, rubidium. These are all different examples of elements that we have on the periodic table. Okay. And then each of these elements are going to be represented on the periodic table with their own chemical symbol. So what is a chemical symbol? Well, remember, those are the abbreviations of an element that we use, in the periodic table. So if we had to write out their full name every single time, we'd be running out of room pretty quick, especially for some of the somewhat man-made elements. It would be pretty difficult because they've got pretty decently long names. So the first letter, remember, when we're writing down chemical symbols, the first letter is always, 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 always capitalized. And if there is a second letter, it's always lowercase. Now that's, again, only if it has a second letter. Not all of them have two letters. So a good example here, hydrogen, H, capital H is for hydrogen, and then a capital A and a lowercase l is for aluminum. And then for calcium, a capital C and a lowercase a. Okay, so it's important to remember that this is the sequence, because when we start writing these out to show like how they bond with one another, you have to write them this way, or else you may get yourself confused, or you incorrectly confuse yourself by showing maybe two atoms that are not being bonded together. Okay. So it's super duper duper important that we get this right. Okay. So on the periodic table, so we get the chemical symbol. Well, not only do we have the chemical symbol, we have what's known as the atomic number. So the atomic number is the number equal to the numbers of protons in an atom of an element. So this is found in the periodic table, and this is always represented by the whole number in like the box for a particular element. Okay. And if you take a peek at your periodic table, you'll notice that we start at the top and we read from left to right, up to down. So meaning when you look at your periodic table, you'll notice that hydrogen is all the way in the top left-hand corner of the periodic table. And if you move straight across, if you move from left to right, you'll see that helium is next. Okay, and if we look at the atomic number, hydrogen has 1, helium has 2. And then if you go down to the second row, then you've got lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. And lithium has 3, beryllium has 4, boron has 5, carbon has 6, nitrogen has 7, oxygen has 8, fluorine has 9, and then neon has 10. So you see how, we go from, smallest to greatest, from top to bottom, and we read it from left to right. And that's what I'm meaning here. Okay. And we should have already seen that pattern before, but just in case you forgot, or in case, you just didn't remember, or you never learned it at all, I should say, that's how we read the periodic table as far as the number of, the atomic number is concerned. So an example, if we look for aluminum on the periodic table, we'll see that aluminum's, the whole number that's associated with aluminum is going to be 13, which means aluminum has 13 protons. Okay. Another example, calcium's atomic number is 20, which means that calcium has 20 protons. So how about you go back real quick, turn back that page real quick, and then go to that little like cutout that I made of the periodic table. Go back, and I want you to there in your notes, label the atomic numbers on that little cutout. It should be between like boron to, I think it's either oxygen or phosphorus. But quickly go back and label, maybe pause the video, label, circle and label which ones are the atomic numbers. Okay, and then atomic mass. So the atomic mass is the average mass of all naturally occurring isotopes of an element. We're going to come back to this word isotope and explain really briefly what that is, just so we're not terribly confused. Think of it in this way. The atomic mass is like just the average masses of all the different types, or the kinds, I should say, the kinds of a specific element. So carbon will have a whole different, number of kinds of carbon. And it's based upon the different numbers of neutrons that these different kinds of carbon have. So the atomic mass just takes the average of all their masses. So this is found in the periodic table, and this is usually represented by a decimal or a fraction. And the average number of protons and neutrons, this is the average number of protons and neutrons found in the nucleus of an atom or of an isotope. Okay, and we don't get really into that. That's something we get more into in chemistry, but it's still important to know which one is the atomic mass, which one is the atomic number. So if we take a peek here at aluminum, again, aluminum's atomic number, or atomic mass, is 26.98154 AMUs. And then calcium's is going to be 40.078 AMUs. So notice that these are a fraction. This is a decimal. So it should be fairly easy to identify, atomic mass versus atomic number. Atomic number, whole numbers. Atomic mass, it's going to be a fraction. It's a decimal. Okay. So go back to that little cutout, that periodic cutout again, and I want you to label. The atomic masses there on that little snip, snap. Okay. Pause the video and then go do that. Once you come back, I'm going to just double check with you to make sure you labeled the right ones right here. So pause the video and then come right back. Okay. So here on the periodic table, this is the little snippet that I was talking about. So let's kind of go through these. So the atomic number, I'm going to outline the atomic number here in blue. So the atomic number, like I said, remember, is the whole number. It's the whole number that's in in each of these boxes. So for boron, it's 5. For carbon, it's 6. For nitrogen, it's 7. For oxygen, it's 8. And for fluorine, it's 9. Okay, so those are the atomic numbers. That's, remember, the number of protons that a particular element has in its nucleus. Now, the atomic mass, remember, this is going to be outlined in red. Remember that this is the fraction, this is the decimal in the box. So that's going to be for boron, the 10.8. For 1, and then carbon is 12.0107, nitrogen is 14.0067, oxygen is 15.9994, fluorine is 18.9984, Okay. And then lastly, I know I didn't ask you to do this, but what are the chemical symbols again? Well, remember, the chemical symbols are just the abbreviations. So boron is B, carbon is C, nitrogen is N, oxygen is O, fluorine is F. Easy peasy, right? Shoot, they even list the names of them right there too. Not all periodic tables do that, by the way. Not all of them have the names listed inside the element box. Okay. So let's keep on trucking. So this is most of this for these next 2 slides are not in your notes, but this is just to, again, cover, because I mentioned the word isotope, and I really couldn't avoid mentioning it. Let's just get into real quick what an isotope is. So an isotope, think of it, the definition is that atoms of the same element, so meaning that you have an element here, so they all have the same number of protons, but differ in the number of neutrons, and so they have different atomic masses. So like in that picture over there to the left on my slides, so you have like different, these are different isotopes of hydrogen. So the one that you find most often is hydrogen 1, but you can have hydrogen 2, which has a proton and a neutron in it, and it has a mass number of 2. We didn't get into mass number, but just realize that it's now has more mass to it. Hydrogen 3, this is where it has, in this case, it'll have 1 proton and 2 neutrons, and now its mass is even increased even further. But remember the number, and if you notice, these are all still hydrogen. They all have the same number of protons in here. So the isotopes don't care, or isotopes are different kinds. Remember, different kinds of a particular element. We can change out, for the most part, you can take away and you can add neutrons, but it's not going to change the type of atom you have, because you still have the same number of protons. It just changes the mass and changes some of the properties, just a little, depending upon the element. I shouldn't say a little bit. Oh, I forgot to take that out. I meant to do it here. So think of it like this. So isotopes are to elements as sweetness is to apples. Like some apples have more sweetness, some have less sweetness, but they are still all apples. Some isotopes of a specific element have a certain number of neutrons, while other isotopes of the same element have a different number of neutrons. So I'm really trying to hit home that isotopes do not equal, different isotopes of a specific element do not equal a whole new element. Okay? You can take out neutrons, you can put in neutrons, and as long as you still have the same number of protons, you still have the same element. Okay? So again, what do they all have in common? All isotopes of carbon have the same number of protons, which is 6. If you change the number of protons, you change the element completely. But if you change the number of neutrons without altering, you can change the number of neutrons without altering the chemical structure of the atom completely. So think of it this way: if you took away one proton from a carbon atom, you now have boron. If you increased the number of protons by 1 in a carbon atom, you now have nitrogen. So protons determine the element. Neutrons determine the isotope of a particular element. Okay, so and maybe you've heard of isotope before, but that's what an isotope is. And I only want to mention isotopes, so because again I had to clarify what it is and what it looks like. Okay, so let's do this. Check your understanding number 2. So again, I'll go through this, pause the video, and then come back and see if what you did on your own was correct. So let's write the appropriate atomic numbers for the provided elements: carbon, phosphorus, chlorine, bismuth, thallium. Ooh, is that thallium? Ta. I may have gotten that. That's thallium. Regardless, whatever it is, Ta. I'll have to find it here in a bit. Calcium and helium. So pause the video here. Associate the correct atomic numbers with these elements by using the periodic table I handed out to you the other day. Okay, so carbon. We've kind of already been going over carbon a couple of times. So carbon's atomic number here is going to be 6. Phosphorus is going to have an atomic number of 15. Chlorine is going to have an atomic number of 17. That's a 7. Oh boy, that's a 7. 17, yikes. Bismuth, let's find bismuth. Oh shoot. Bismuth is going to have an atomic number of 83. Ta, wait, and I still couldn't find that Ta. There it is. Tantalum. Tantalum has an atomic number of 73. Calcium has an atomic number of 20. And then helium has an atomic number of 2. Okay, so this is what you should have found based upon reading the atomic number, or sorry, the periodic table. Okay, that's what you should have found. All right, now let's go to number 3. So now let's kind of look at the atomic mass. So write the appropriate atomic mass for the provided elements for hydrogen, rubidium, sulfur, aluminum, neon, oxygen, and thorium. So find these guys on the periodic table, write down the appropriate atomic mass, and then check them against me. So pause the video here and then come back after you filled those out. Okay, so hydrogen, should have found out that hydrogen here has an atomic mass of 1.00794. Rubidium, you should have found has 85.4, 4678. Sulfur has a, where is it at? Sulfur, I lost it. Sulfur has an atomic mass of 32.065. Aluminum has an atomic mass of 26.981539. Neon has an atomic mass of 20.1797. Oxygen has an atomic mass of 15.9994. And then thorium, let's see, where's my TH at? Thorium. I lost it. I just had it. Let me find it. I'm finding it. Hold on. TH. Where is TH at? There he is. Thorium, you should have found, is 232.03806. Okay. And all these are AMUs. Okay. So those are what you should have, that's what you should have found for all of the atomic masses for each of these examples here. So let's keep on going. Okay, so check your understand number 4. You have 2 atoms in your hand, just as an example, or as this kind of weird scenario. One is super common and is the most abundant atom of this kind and has 6 protons, 6 electrons, and 6 neutrons. The second atom isn't as common and has 6 protons, 6 electrons, and 8 neutrons. So what element do we have here? So, and then the next one, what are these examples of? So I want you to pause the video here, answer these 2 questions, and then come back and then see, double check your answers with me. Okay, so for number 1, I know off the top of my head, but maybe you had to look into your periodic table, but 6 protons, that tells me immediately that what I'm working here is that we are working with carbon. Okay, and remember, how do I know that? Well, 6 protons, well, that means 6 protons that's the atomic number right there. Okay, so then if I see that there's 6 protons, I just go to my periodic table and see that which one has an atomic number of 6, happens to be carbon. So we've got carbon here. We've got 2 atoms of carbon, but 2 different atoms of carbon. So number 2, what are these examples of? Hopefully you guessed it. These are examples of isotopes. So what you have here is that you've got 2 different isotopes of carbon in your hand, per se. You've got one that has 6 neutrons, and then you've got one that has 8 neutrons. Okay, so these are 2 different isotopes of carbon. Okay, but remember, they both have 6 protons. So because they have 6 protons, they're both still carbon. They just have a little different masses, going on, and so they're just 2 different isotopes. Okay, good. And then the last one, number 5 here. Now that we know where things are located and how to read the periodic table, let's draw a couple of atoms using the provided information. So atom number 1 has 20 protons, 20 electrons, and 20 neutrons. Atom number 2 has 14 protons, 14 electrons, and 14 neutrons. So let's pause the video here, try to figure out what locate these on the periodic table, and then figure out who they are, and then draw them. Similar to how we drew them in class the other day. Okay, so let's just focus in on atom number 1 here. So real quick, I know based upon looking at my periodic table, it looks like atom number 1 is going to be, let's see, 20 protons. So that's going to be calcium. So we're working with the calcium atom here. So let's just quickly draw what I'm looking for here. So I'm just going to use little dots like this. So and these are going to be my protons. This color is going to be protons. Okay, so 1, 2, 3, 4, 5, 6, 7. There's 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So that should be 20. I might be off by 1 or 2. Okay. And then let's put in my neutrons. And there's 20 neutrons. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So there's my nucleus. And then now I need to do electrons. electrons are going to be green. And so I've got 20 electrons. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and then 20. Okay, so then there are all my protons. And here is my, for the most part, here is my atom here's my atom of calcium. Okay, there's my nucleus. The green circle is my electron cloud. We're all good to go. Nice. So that's what I'm looking for here. And then atom number 2. So we've got an atom here that has 14 protons. So I'm going to look on my periodic table for whoever has an atomic number 14, which it looks like this is silicon. Silicone, however you want to pronounce it. There is no E, by the way, in this guy. Okay, it's not the building product. It's not the sealer product. This is silicon. This is the element. You can pronounce it different ways, obviously, but anyway. Okay, so this guy has 14 protons. So I'm going to draw this. Let's see. That's right. I use this like cyan color for my protons. He's got 14. So 1, 2, 3, 4, 5, 6. Come on, 7, 8, 9, 10, 11, 12, 13, 14. Okay. And then I'm going to draw my neutrons, which is going to be 14. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So there are my neutrons. And then my electrons are going to be green again. My electrons, there's 14 of them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So then there's my electron cloud. And then here is my nucleus. And I have my atom. Perfect. Okay. And again, that's silicone. Okay. Nice. All right. And those are the notes, guys. So thanks for bearing with me. If you still have any questions, make sure you ask me any questions that you may have. If not, then I will see you in class and I'll see you in the next one.